What if geometry had a no exceptions promise, and then one construction shows nope? In 1960, Borsuk asked whether any bounded set in d-dimensional space can be chopped into d+1 smaller diameter pieces. Small dimensions behaved, then high dimensions started breaking the promise. This paper targets dimension 63. The result is wild. They build a 321-point set in R to the 63, and they prove you cannot partition it into 64 subsets of smaller diameter. That's not just hard, it's mathematically impossible. Here's the intuition. Think of each point like a person in a club, and small diameter like being able to sit at a distance from everyone without crossing a forbidden separation. The authors use a graph theory trick to control which groups can coexist. They start from a known strongly regular graph, G2 of 4, also written as G2 of 4. That graph has a powerful property. Its largest clique has size 5. In their graph to Euclidean dictionary, cliques correspond exactly to sets of points that can fit inside one smaller diameter subset. So if every smaller diameter subset can contain at most 5 points, then 64 subsets would cover at most 320 points. But they make 321 points. That's already game over. Now the AI twist, or at least the clever, nearly done engineering. Genrich and Brouwer had a 320-point core that lived inside a 63-dimensional subspace. It wasn't a full counterexample by itself. This paper adds one more point, but it's careful. They take a point from a 65-dimensional realization, project it down into the 63-dimensional subspace, and then rescale it so it lands at the full critical diameter with exactly the right neighbors. Nearby in the geometry means adjacent or non-adjacent in the graph, like two people being compatible or not compatible on a strict seating chart. The compatibility graph stays the same, so the clique obstruction survives. And since the graph still has clique number 5, no partition into 64 smaller diameter pieces can exist. So we just witnessed geometry lose in dimension 63. If you want more AI-driven math breakthroughs, follow and tell me in the comments, should we try dimension 64 next?